Welcome back everyone. So in today's video we will be going through a bit of theory, and our topic for today is on the differences between databases, data warehouses, and data lakes. Alright, so these terms are popularly used in data world, and in today's video I just wanted to go through a very high level overview on what these terms are and how they relate to each other. Okay, so let's jump to it. Okay, so the first one that we'll be looking at is a database. Okay, so what is a database? So a database is designed for day-to-day activities or operations, and these are things like applications, websites, or business systems. So when you want to think about it, think of like fast reads, writes, small transactions, and these are basically highly structured. So for example, if you go to a website and you purchase an item, for example, if you go to Amazon website and purchase anything from there, the transactions that you make are actually stored in a database. Okay, or if you go to a store, for example, you go to Walmart and you purchase an item, when you go check out, those activities are stored within a database. So this usually captures operational activities. Okay, and in terms of its primary purpose here, again I mentioned that this stores operational data. So you might come across this term called OLTP, online transactional processing. Okay, so when you see this term, think of a database. Okay, so this again stores operational data. Okay, so this is for operational processing, and this is online transactional processing. Okay, so it is designed for high-speed, real-time data input, retrieval, modification, and it supports day-to-day business operations. Okay, so I mentioned again, if you go to a store and purchase something, that data is stored within a database. Okay, so that's how you can think about it if you're confused on what the database is. It basically stores your operational day-to-day activities. All right, and in terms of the data that it stores, these are usually structured data. Okay, so it is highly organized and adheres to a predefined schema. So behind in the back end, you will have a predefined schema that will be storing a data. So for example, let's say a customer ID or an order ID, all of those schemas or fields or rows are already predefined, and whenever you purchase the item, by default the data gets stored within that column. Okay, and then in terms of data characteristics, okay, so we mentioned that this is operational data, so it will store and capture the current state of your data. Okay, so this is going to focus on the most up-to-date data information, and it's also normalized. Okay, so data is often normalized to reduce redundancy and improve data integrity. So what this means is instead of putting all of your data within the same database, then you separate them out. So you can have orders in one table, you have customers in another one, or you can have employees in another one, and then you have their salary information on another table. So basically you separate related fields and you join them using similar keys. So for example, you can have foreign key relationship between tables. So that's what normalization means. Okay, and then so later when we cover data warehouses, it actually uses the opposite side. So the data in data warehouse are denormalized, where you can have redundancy within the same table. Okay, so that is one of the characteristics of a database. Okay, so the data is highly normalized. And then some of the typical users that you will come across in a database, so we will have application users, business analysts running operational reports, or software developers. Okay, so basically these are users that interact with day-to-day data within a database, okay, or within a company. And then so these are some of the examples of operational data stores or databases, and these are quite popular. Okay, so you will have MySQL. So MySQL stores operational data. You will have PostgreSQL or PostgreSQL, and then we have SQL Server, Oracle database, or a MongoDB for operational use cases. Okay, so these are some of the popular databases that store operational data. Okay, so MySQL, Postgre, SQL Server, Oracle. And then for use cases, online banking transactions is one of them. So if you go to online login to your a bank account, for example, and then make some transactions, either purchase an item or send somebody some money, that's one of the use case for a database. Whenever you do that, your data is stored within a database. We also mentioned e-commerce, shopping carts. So if you go to Amazon, for example, and purchase an item, that is stored in the backend within a database because you are doing operations and real-time activities, okay? And then we have inventory management systems and also customer relationship management, CRM systems. These are also good for database use cases. In terms of advantages, databases are pretty excellent for transactional workloads, okay? So again, OLTP, and then it will ensure data consistency and integrity, okay? So for ACID operations, and ACID are things are like if you want to create, delete, and things like this, that is one of the advantage for database. A database does pretty well when it comes to ensuring data consistency and integrity between your tables. And also, we didn't mention earlier about normalization. So this is where your tables again are related. You know, you have different tables holding kind of similar data. If you want to ensure consistency across all of these tables, you can put constraints and foreign key relationship. So that's where a database excels in, okay? And then fast query performance for specific small data sets, okay? So this is when you want to query a database, especially for small data sets, it does well. Now, when the data becomes large enough, then it doesn't do so well, and that's where a data warehouse comes in. Okay, and so some of the disadvantages are not optimized for complex analytical queries across large data sets. Okay, so that's what we just mentioned, that if you have millions of records or billions of data or terabytes, a database is not really good for that. So if you want to query that, then you may want to use a data warehouse. And also another disadvantage for a database is that it can become a bottleneck for historical data analysis. Again, this is for operational data stores. So if you want to run historical data analysis, you may not want to use a database. Data warehouses are pretty much good and designed for that. All right, so let's move on now to a data warehouse. So what is a data warehouse? So a data warehouse is built for analytics, okay? So think of this as huge data sets, complex queries, and reporting, okay? So if you want to run reporting against your data, then you may want to put that in a data warehouse. And the reason for this is because data warehouses are designed to store large amounts of data and optimized for read, okay? So again, databases are for creates, DDLs, you know, updates, real-time updates. But if you want to run analytics, then a data warehouse is where you want your data to be in. Okay, so again, in terms of storage, this one stores cleaned and structured data from different sources. So you can have your data coming from different sources. You want to put that in a different data mats or different sections within your database or data warehouse, and then from there you can run analytics on top of that. One thing that now comes into this is this concept of ETL or ELT. Okay, so ELT or ETL stands for, so for ETL it stands for extract, transform, load. So this is basically where you are extracting your data from your sources. So you can see in this diagram here we have data coming from different sources. You can have CRM, billing, ERP, or flat files. You extract that data, and then in some instances, you may want to transform that data before you load it into your data warehouse. And then from your data warehouse now, that is where you have your cleaned, structured, and conformed data, whereby you can start running reports against that data. Okay, so you can see here, once you transform your data, you will have your data in different data mats or sections within your database. And then from there, you can run reporting, analytics, or data mining once you have that data in your data warehouse. The other concept of this one is ELT. Okay, so that is extract, load, transform, and that one is more recent kind of concept. And what happens with that one is you extract the data and you load it before you transform. So for cloud data warehouses, for example, like Snowflake, BigQuery, Redshift, it does support this concept of ELT. So you can extract your data and dump it into your data warehouse, and then from there you can run an analytics against that. Okay, so both of these concepts, ETL or ELT, do pretty well with data warehouses. Okay, now we go into the primary purpose again for this one is this concept of OLAP. So you may have seen this OLAP word, and this stands for online analytical processing. Okay, so when you see OLAP, think of a data warehouse, and basically this is optimized for complex queries and analysis for historical and aggregated data to support business intelligence and decision making. Okay, so again, at data warehouses, their primary purpose is for analytics. If you want to run queries against your data, you want to put that data in a data warehouse. And then in terms of the data that is stored in a data warehouse, this is primarily structured data. However, it can also support to some extent some semi-structured data. So if you have JSON data, for example, you can still store that within a data warehouse and then run some SQL queries or Python queries to flatten that data out. Okay, so it does primarily support structured data, but to some extent it can also support some unstructured data. Okay, and the data characteristics for the data in data warehouse. Okay, so we have historical and summarized data. And so data warehouse contains historical data, and this one is often aggregated over time. It also supports pretty denormalized data. So this is the opposite of normalized data, and what this means is data is typically denormalized. The reason for this is for faster query processing, and this is often using star or Snowflake schemas. So you might end up with a bit of redundant data when you denormalize it, and the reason for this is because we want to just make the queries faster. Now think about this way, like if you had your data sitting in different tables and you want to bring that data over to run analytics on top of that, then you have to do a lot of joins. And if you have millions or billions of records or tables that you are doing joins, then your queries may run for a very long time because it has to go through all of those tables and bring the data over. So it has to scan billions of records, and that's not very good if you're running analytics. So that's why most of data warehouses have denormalized data so that your analytics queries can run much faster. All right, and then we also have the data that is in data warehouses are most of the time they are subject oriented. And so data is organized around major subject areas like sales, marketing, finance. So this is a concept of data mats where you're putting related data in specific kind of like tables or schemas kind of thing. Okay, so this makes it easy for let's say you have folks from sales and they want specific sales data, then they know where to go. The same thing with marketing and billing and things like that, right? So data is stored in a subject-oriented manner within a data warehouse. Okay, so we also have the concept of time variance, and if you want to run like time series analysis, then you will have kind of like time or dates included with your data. Okay, so data includes time dimension. So for example, if you are bringing data and loading it into your data warehouse, you may have to do like when the data was loaded, right? Data loaded or things like that, so that when you run your analytics, you can partition based on that and only query for specific time in period, because this is historical data. You may not want to store like query records that was loaded into your database 10 years ago, right? So if you just want to run queries for a specific time frame, then they are usually dates within your data that that you can query and only filter within that range. Okay, so data in data warehouse also is non-volatile, and what this means is that once data is in the data warehouse, it generally remains stable and is not updated or deleted. Okay, so again, data warehouse supports kind of read only, is optimized for read only. Now if you want to do a lot of updates and deletes and things like that, then that's where a database does best. Okay, so most of the time the data that you have in your data warehouse are not updated that much. Okay, you ingest it and then you just keep appending new rows as they come. All right, and then so for users, the typical users for a data warehouses, for a data warehouse are a business analysts, we have data scientists, executives, or reporting tools. Okay, so these are folks who just want to run analysis and get some insights on the data. So data scientists may want to run some models, data analysts may want to run some create some dashboards on top of the data, or executives who just want to know how the company is doing and all of that, right? Okay, and some of the data warehouse examples that we have, all right, so we have Snowflake, which is one of the very popular cloud data warehouse currently. We have Amazon Redshift, Google BigQuery, we have Teradata. This is, I believe this supports on-prem as well as cloud now, and we have Azure Synapse Analytics. Okay, so these are some of the popular data warehouses that are out there. And so when it comes to use cases, data warehouse is good for sales trend analysis. If you want to see trends on your sales, then you can run reports against your data in data warehouse. We have customer behavior analysis. Okay, so you want to analyze how your customers are behaving, then you will be running analytics against your data in a data warehouse. Financial forecasting and performance monitoring dashboards. Okay, some of these, I mean, we have a lot of other use cases, but these are just some of the few ones where data warehouse shines. So some of the advantages of a data warehouse, we have optimized for analytical queries and reporting, right? We have mentioned this a bit. It provides unified and consistent view of business data. It also supports historical analysis and trend identification. Okay, so these are pretty good benefits for having a data warehouse. When it comes to some of the cons or disadvantages, it requires significant upfront design in ETL, and this is extract transform load or extract load transform. So what basically this means is that if you want to design a data warehouse, then you have to think about this process, right? How do you design your ETL or ELT? Where is the data going to come from? How do you structure your tables? To put that in place might take some time. It's also less flexible for new unstructured data types, and it can be expensive to build and maintain. Okay, so let's move on now to data lake. Okay, so this is the last one here that we have. So what is a data lake? So a data lake is a fast centralized repository that stores massive amount of raw data in its native format, regardless of its type. Okay, so it can store logs, images, videos, CSV, basically anything, right? So think of a lake. A lake, whenever it rains, it all sorts of things go to a lake. So that is the same concept why it's called data lake, because you can pretty much store anything on a data lake. Okay, and if you look at this diagram on the right here, you're bringing your data from various sources and you are storing that data in its raw form. So you're not doing any sort of modification. You're basically dumping it into your lake, and then from there you can now think about how you want to use that data. So you can run some transformations against the data in your lake, and then even on top of that, either load it to data warehouse, load it to a database, or even run machine learning or some sort of reporting on top of that data. So what the concept is, you want to ingest data. Okay, just get the data, bring the data over to your lake, and then from there you can decide what to do with that data, right? So that's the concept, and you store it in a raw format. You're not modifying any of the data that's coming to your lake. Okay, so in terms of the primary purpose, again, we have mentioned that this is a big data storage and exploration, and it is designed to store all data, structured, semi-structured, unstructured, and this is usually for future use cases, including advanced analytics, machine learning, and data exploration. The type of data that you store here, again, are structured, semi-structured, so JSON, XML, log files, videos, all of that. And unstructured data, right? Audio, videos, images, free text, anything you can store in your data lake. Okay, some of the other characteristics for the data that we have here: raw and untransformed, right? So data is stored as it is with minimal or no upfront processing. It also supports schema-on-read. So what this means is the schema is applied when the data is read and analyzed, not when it's stored. Okay, which is different, kind of different with data warehouses and databases, because with databases or data warehouses, before you load your data, you have to define the schema and the data type before you load the data. Now with data lake, you don't need to worry about that. You basically dump the data into your lake, and then now when you want to read the data, then you can apply the schema, right? So that's what that means. And then scalability, it's quite scalable, and it's designed for massive scalability. So it can store terabytes and petabytes of data. So you don't worry about storage here. And then typical users for data lake, we have data scientists, machine learning engineers, data engineers, or advanced analytics teams. Okay, so these are folks who just, for data scientists, they may want to run some machine learning or models against that data. Machine learning engineers also. These roles sometimes are a bit interchangeable, because you can have data scientists who are doing machine learning or AI stuff. Data engineers are usually building the infrastructure and putting the ETL in place, pipelines and all of that. Or advanced analytics teams, folks who want to run data on the data lake. If they don't want to have this data code to a data warehouse or anything, they can go to the lake directly and just get what they need. So examples of data lakes, we have Amazon S3. This is very popular. Azure Data Lake Storage, we have Hadoop HDFS, and Google Cloud Storage. Okay, so Hadoop is one of the first one that came 15-20 years ago, but recently, since a lot of companies have been moving to cloud, now you've had options like S3, Azure Data Lake Storage, GCS or Google Cloud Storage. These are object storages. So you basically load all of your data as it is, and then from there you can either decide to run analytics on top of the data there, or you can load it into your data warehouses, right? And some of the use cases that we have here, we have machine learning model training, predictive analytics, real-time analytics or on streaming data, exploratory data analysis, or Internet of Things data storage and analysis. Okay, so if you have IoT sensors, you can ingest that data from IoT into data lake, and then from there you can run your analytics on top of that, right? And then the advantages of a data lake, so highly flexible and can store any data type, right? Okay, so we have mentioned that. Cost effective for massive amounts of data. Now 10 years, 20 years ago, if you wanted to ingest this type of data into on-prem data, then you needed quite a bit of storage, and even the cost for that was quite a lot. But now with these data lakes, it's not very costly anymore. I mean, it can go up, with your data storage, how big your data is, but at its basic form, it's not as costly as other storage methods, right? It also enables advanced analytics and machine learning applications, right? So if you want to run your machine learning, you can just basically put your data in your lake, and then again run analytics and machine learning on top of that. Schema-on-read approach offers agility. Okay, so you don't have to worry about the rigid schema predefined and then you load the data there. This one you don't have to worry about. You do the schema-on-read. So basically you are applying schema when reading the data. All right, and then some of the disadvantages here, it can become a data swarm. Okay, so it can become messy, and this one now, like so for governance and metadata management and organization, it's not very good for data lakes to apply these things. So it can be a bit of a swarm for that, kind of messy. It requires specialized skills, data engineering, data science to extract the value. So again, these are quite unstructured data, so you do need some specialized skills, maybe to some extent some coding skills to extract the data out of those unstructured or even structured data that you have in your lake. The data quality and security can be a bit challenging to manage, right? So that's just one of the disadvantages here for data lake. And then so this is a summarized view for just basically all of what we've been talking about for the differences between databases, data warehouses, and data lakes, right? So here, just quickly, on purpose here, you have like for databases, it's good for operational processing. The data is structured. The schema is schema-on-write, define the schema, and then you basically write the data to the schema. The data that you store are pretty current, volatile, it changes a lot. And then for optimization, this is optimized for read write, and then also there is some data integrity that is enforced on a database. And then the users here applications or operational reports. The cost is also moderate. When it comes to data warehouses, this is good for business intelligence. The data type is also pretty structured. And then we have schema-on-write, also historical or non-volatile is the data state, okay? And then optimization, the data is optimized for read or complex queries. And then the users here, we have business analysts or executives. The cost for a data warehouse is moderate to high, so it depends with the amount of data that you store. And then for a data lake, the purpose is for big data storage, advanced analytics, and then the data type is structured or semi-structured. It is the schema is schema-on-read. Raw and transformed is the data that you put there. And then for storage, the storage can be flexible. It can go high in some extent. And then the users here, we have data scientists, engineers or data engineers, ML engineers or data engineers. And the cost here again is low per unit storage, but it can be massive, as you know, depending on the amount of data that you store there. All right, so what's the conclusion for all of this? One of the conclusion here, or one of the takeaway that you can put on this one, is there's no one size fits all. Okay, so the best solution here depends on your specific business needs, data types, volume, and analytical requirements. It is complementary, not exclusive. Okay, so basically in many modern data architectures, these solutions often coexist and complement each other, forming a robust data ecosystem. So for example, you can have data from operational databases feeding into a data warehouse, or you can have a data lake that is serving as a primary ingest point for all of your raw data, and then from there you can direct it into either a data warehouse or a specialized database. So if you want to consider, all right, so if you have operational needs, then you may want to use a database. For historical analysis and PI, you may want to use data warehouse for that. And then for big data, machine learning, and future exploration, you will want to use data lake for that. All right, so that is just a quick overview of the differences between databases, data warehouses, and data lakes. There's a bit more on these topics. I will be covering more as we move forward, but I just wanted to quickly go through the high level differences between databases, data warehouses, and data lake, and I hope this video was helpful. We will be digging deeper as we move on. Please do let me know what you think about this, and if you're interested, we can dive into some specific topics around this area. So let me know what you think about this topic. But again, that's what I had for today, and I hope this was helpful. And if it was, please give it a thumbs up, and also do subscribe to the channel. All right, guys, I will see you then in the next video. Bye bye.